Hey everyone, and welcome. Let's talk about something incredible that's happening right under our noses, or, well, right on our wrists. We're diving into the world of AI that's constantly analyzing health data from the devices we use every single day. So the big question is, could your watch be the new doctor's office? Let's get into it. So it really all kicks off with this one number, 85%. That's how many Americans own a smartphone. And this isn't just about making calls anymore. What it really means is that nearly all of us are carrying a powerful health sensor in our pockets, creating this absolute flood of data about our lives. Now, this flood of data is actually sparking a quiet revolution in personal health. It even has a name. And to really get a grip on its power, we've got to understand what we're even talking about. It's called person-generated health data, or PhD for short. And the most important word there isn't health or data, it's person, not patient. This is the data that can tell us something about your health long before you'd ever think to go see a doctor. It's basically the story of your well-being, written by your daily life. And believe me, the scope of this is just exploding. I mean, today, we're all familiar with the basics, right? Heart rate, steps, sleep tracking. But your phone, just sitting in your pocket, can already measure complex things like how stable your walk is. And tomorrow, we're talking about health data coming from our clothes, our cars, even our beds. It's going to be everywhere. To make this super concrete, think about something called the 6-minute walk test. It's a gold standard in clinics to measure heart and lung health. It usually requires a doctor, a long hallway, the whole shebang. Well, your watch can now estimate that same metric, passively, just by analyzing how you move around every day. It's giving you a powerful vital sign, week after week, without you doing a thing. Okay, so having all this data is one thing, but making sense of it, that's a whole other challenge. And that's where our digital detective comes in, artificial intelligence. Honestly, it's the only tool we have that's powerful enough to find the meaningful clues in this nonstop stream of information. You know, a doctor is trained to spot the obvious patterns, but machine learning, it does something different. It wades through all that noise and finds these incredibly subtle predictive signals, signals that are completely buried in mountains of data and are literally invisible to the human eye. So this brings up a really fascinating question. We all know our watches aren't medical-grade ECG machines. So how in the world can they detect something as serious as atrial fibrillation, a really tricky type of irregular heartbeat? It feels like it should be impossible, but it's not magic. It's just really, really clever data science. Here's how it works. First, you basically send the AI model to school. You feed it thousands and thousands of hours of heart rhythm data collected from a watch's simple light sensor. Over time, the AI learns to recognize the tiny, almost imperceptible flickers in that data that are telltale signs of AFib. Once it's graduated, it can apply that knowledge to your data, acting like an always-on early warning system. And let me be clear, this isn't some pie-in-the-sky future we're talking about. This technology is already here, and it's growing at a blistering pace. The number of AI medical devices getting the green light from the FDA is just soaring. These digital detectives are quickly becoming a standard part of modern healthcare. But, and this is a huge but, with all of this amazing promise comes some very serious risk. We have to pump the brakes and talk about the other side of the coin here, the really deep and dangerous pitfalls that can happen when we hand over health decisions to an algorithm. This might be the single most important question we have to ask ourselves. An AI is only as smart or as fair as the data it learns from. So what happens when that data is just a reflection of the biases and inequalities that already exist in our society? Well, here's a real-world example of how a logical-sounding assumption can lead to a terrible outcome. A major algorithm used by hospitals assumed that people who spent less on healthcare must be healthier. Makes sense, right? Wrong. The reality was they spent less because they couldn't afford care. So the AI learned this flawed lesson and started assigning the sickest, poorest people to get less care, making a horrible problem even worse. And then there's this, which sounds like something straight out of a spy movie: adversarial attacks. This is where someone can intentionally add a tiny amount of digital static to raw health data. To a human doctor looking at it, it's completely invisible. But to the AI, that little bit of noise can completely trick it into making the wrong call, seeing disease where there is none, or worse, missing it when it's there. And on top of all that, there's a huge reliability problem. When researchers looked at a bunch of different AI models that were all trying to do the same thing, detect COVID-19 from wearable data, the results were all over the map. I mean, some were impressively accurate, but others were literally no better than a coin flip.
Without a standard for quality, how can we possibly trust any of them?
So the challenges are pretty clear. We've got bias, security threats, and unreliable results. But the story doesn't end there. The good news is, researchers are now laser focused on building a new framework, a way to create AI that we can actually trust, with something as important as our health. A massive piece of this puzzle is something called community benchmarks. The best way to think about this is like a universal, standardized test for all health AI. Everyone uses the same public, high-quality data to train and test their models. This way, we can finally compare them apples to apples in a totally transparent way, which pushes the entire field to get better. Building this kind of trust really means we need a whole new checklist. It's not just about how accurate is it anymore. We have to test models on data they've never seen before. We need data nutrition labels so we know exactly what went into them. And we have to start grading these things on fairness, safety, and privacy just as hard as we grade them on performance. Ultimately, what this all boils down to is that making trustworthy AI isn't really a coding problem, it's a human problem. It demands that we commit to being open, to testing everything rigorously, and to working together to build systems that aren't just powerful, but are also fair and safe for every single one of us. So as we're standing right here on the edge of this incredible new world, we're left with a really profound question to think about. The data from your watch, your phone, your life, it tells a deeply personal and powerful story about you. And the crucial question that we all have to answer now is, who do we trust to read it?